Okay, guys, today we are in our pink packets for chapter 5 for ratios and proportions, and we are working on lesson 7 notes. That's on page 16. So our topic is we're going to talk about how to graph proportional relationships. And by the end of this lesson, hopefully you guys will be able to tell if a relationship is proportional just by looking at the graph. So since we're talking about graphs today, we're going to review some key vocabulary words that hopefully you guys are somewhat familiar with. The first one is the coordinate plane. The coordinate plane is this whole image to your right over here on the right of the page with the graph and the y-axis and the x-axis. That's all the coordinate plane. Let's talk about the quadrants. The first quadrant is where we start, where it's always positive. This is quadrant number 1 that I outlined in the blue. Quadrant number 2 has a negative x and a positive y, outlined in the green. Quadrant number 3 is outlined in the purple. It's always negative. And quadrant number 4 is outlined in red with a positive x and a negative y. All right, I'm going to clear that off because it's a little bit messy. And let's talk about the y-coordinate. The y-coordinate is the value that you get on your ordered pair on the y-axis, and your x-coordinate is the value that you have on your x-axis. So your x-axis is here, it's horizontal, and the y-axis is here, it's vertical. An ordered pair is what we use to identify different spots on the graph. So we start with an open parentheses. Our x value goes first, separated with a comma, and our y value goes second. So if I wanted to write an ordered pair for this spot on the graph, my x value is 3, so that goes first, and my y value is 1, so that goes second. So I can use the ordered pair to locate that spot on the graph. Finally, our origin is right here in the middle of our graph, and it lies at 0, 0. So that was some quick review. Now we're going to talk about the relationship between x and y values on the coordinate plane. The y variable is the output, and it is always dependent on the x variable or the input. So the x variable can be anything we want. It is independent. It does not depend on anything. It's on its own. But the y variable always depends on whatever x is. So that is our dependent variable. So when we are looking for our independent and dependent variables, we need to think, what depends on the other thing? So let's try some examples. Example A, Mr. Krankovich uses 13 gallons of gas to drive 250 miles. So if you think about driving a car and putting gas in your car, if you have a full tank of gas, you can drive a lot of miles. But if you only have a half tank of gas, you can't drive nearly as many miles. So the number of miles that you can drive depends on how much gas you put in your car. You can choose to put a certain amount of gas in your car, and then that will determine how many miles you are able to drive. So our independent variable is our amount of gas that we decide to put in the car, and our dependent variable is the number of miles. In example B, it talks about the number of toppings on a sub and the cost of a sub. So our two variables are the number of toppings and the total cost of the sub. So I can choose however many toppings I want to put on the sub. It doesn't matter. I can choose 2 toppings. I can choose 5 toppings. But the cost of the sub depends on the number of toppings I choose. If I choose 5 toppings, that's going to be more money than if I only choose 2 toppings. So the independent variable is the number of toppings, and the dependent variable is the cost of the sub. All right, let's flip our pages. Take a look at example C. The grade I get on my test and the number of minutes spent studying. Well, if we look at our first page, we were given a clue here that time is independent 99% of the time. So words like minutes, hours, seconds, those are all key clues that that variable is going to be the independent variable. But since it's only true about 99% of the time, we still have to think about if that actually makes sense. So in theory, the more minutes you spend studying should improve your grade. So it doesn't matter how many minutes you spend. You could spend 10 minutes, 20 minutes, 30 minutes, or 100 minutes. But the more minutes you spend studying, the higher your grade is going to get. So your grade depends on the number of minutes you study. So the independent variable is time, or number of minutes, and the dependent variable is your grade. All right, let's look at example D. We have the total cost for music downloads. So on your iPhone or whatever phone you have, you can download however many songs you want. You can download 1 song or you could download 100 songs. But the more songs you download, the more you have to pay. So the total cost depends on the amount of music downloads. So the independent variable is number of music downloads. You can choose however many you want. And the dependent variable is the total cost, because the cost depends on the amount of downloads. Finally, we're going to look at E, the number of tables a waitress serves and the amount of tips earned. So again, in theory, if a waitress serves more tables, she'll earn more tips. But the amount of tables, she can choose how many tables she decides to serve. So if she chooses to serve 10 tables, she'll make more money than if she decided to choose 4 tables or serve 4 tables. So the independent variable is the number of tables, and the dependent variable is the amount of tips, because the amount of tips she earns depends on the number of tables she serves. All right, and our last example on this page, a Redbox rental. I don't know if you've ever seen a Redbox. Sometimes they're outside of Walmarts or grocery stores. You pay money and you can rent a DVD. I know DVDs aren't super popular anymore, but maybe you've seen them around. A Redbox rental charges $1.75 per movie rental. So we have to think, what represents the independent variable? X. So I can choose to rent 1 movie, or I can choose to rent 10 movies, or I can choose to rent 30 movies. It doesn't matter. I can choose to rent as many movies as I want. So the number of movies rented is our independent variable. What is dependent is the total cost that I end up spending on movies. If I only rent 1 movie, my total cost is going to be significantly less than if I decide to rent 10 movies. So the total cost depends on how many movies I decide to rent. So as we see here, our independent variable is always represented by our x. So x in this column is going to be number of movies. And our y in this column is dependent, and it's going to be our total cost. So if I decide to rent no movies, I don't have to pay any money. But if I decide to rent one movie, I know that I have to pay $1.75. If I decide to rent two movies, well, now I have to do a little bit of math to figure out how much I have to pay. Up here it says it's $1.75 per movie. Per is a multiplying word. So 2 times $1.75, that would be $3.50. And then if I wanted to rent 3 movies, then I would have to pay $5.25. Again, because that would be 3 times 1.75. You guys can use your calculators if you're not so good at multiplying decimals. So when we decide to make our graph, I'm going to label that the x-axis, and I'm going to label this the y-axis. Again, our independent variable is represented on our x-axis. So I'm going to label this with our independent variable, which is number of movies. Our dependent variable always lies on the y-axis. So I'm going to label the y-axis with total cost. I'm going to start with 0 in our corner here or at our origin. And now I'm going to label this 1, 2, 3 for different types of movies. And I decided to skip a tick mark so I could see this better. Now I'm going to label this y-axis in increments of 50. So then this is $1 and $1.50, $2, $2.50, $3, $3.50, $4, $4.50, $5, $5.50. All right, so now I'm going to choose a different color. If I rent 0 movies, I will have to pay $0. So I'm going to mark a point there. If I rent 1 movie, I have to pay $1.75. And even though that's not perfectly labeled here, I'll put that point somewhere in here between the $1.50 and the $2. If I decide to rent 2 movies, I have to pay $3.50. That's up here. And if I decide to rent 3 movies, I have to pay $5.25. So that's somewhere around here. And now I'm going to connect these all with a line and finish it off with an arrow. So now this is asking me, is it a proportional relationship? To decide if it's a proportional relationship, let's look at this box in the bottom right corner. It says a graph represents a proportional relationship if it has a straight line that goes through the origin. So those are the 2 questions that we're always going to ask ourselves. Is it a straight line, and does it go through the origin? So this looks pretty straight to me, even though I didn't draw it completely straight, but it is straight. So that checks off. And then does it go through the origin? Well, we know that the origin lies at 0, 0. And if we don't rent any movies, we pay no money. So our graph goes through 0, 0. So yep, it goes through the origin. So since these 2 things are checked off, we can say, yes, this is a proportional relationship. All right. Oh my gosh, was I not recording this? Oh, do I have to stop the share maybe? I thought I did too. Oh, there we go. Maybe this? Oh, no, not stop video. It's definitely recording. I just don't know how to stop the recording. Oh.